Okay, so now we're going to take a look at a situation where we have friction. Mass 1 over here is 10 kilograms, and mass 2 is 5 kilograms. And what we have is a coefficient of static friction for mass 1 is 0.3, and the coefficient of kinetic friction is 0.2. So the question is, first, will it move? And to do that, simply what you have to do is you have to make sure that the force of gravity here is greater than friction, because if it is, static friction, right? Because if it is, it will move. So that's all you want to do starting out. You just want to think, okay, is friction greater than the force of gravity? And if it is, it will move. So you can go ahead and calculate the force of static friction. That's less than or equal to the coefficient of static friction times the normal force. And in this case, we want the equal. We want to figure out, okay, what's the maximum? And then once we do that, if mg of this is greater than the friction acting backwards, we know it'll move, and then we can do the full process of looking at the kinetic friction. So go ahead and do that. Calculate the static friction, calculate the force of gravity for mass 2, and see which one will win, and see if it will actually move. So go ahead and pause the clip, and you can try that, and then hit play and continue. Okay, so it will move. The force of friction static is only 158.76. The weight, or the force of gravity here for mass 2, is 284.2, so it will move. So now we can move on to the actual motion of the masses, and that's what we'll do now. So now what we're going to do is set up the free body diagrams just like we did before, but now we have an extra force of friction. And so why don't you go ahead and try that. Hit pause, set up the free body diagrams, set up the sum of the forces, and see if you get that right. So we'll call, again, the positive x this direction here as it going down, and then the negative x this way. So as you add up your forces, you can set it up in that convention. Okay, so let's see how you did. We've got the tension force going to the right, force of friction going back, normal force, force of gravity opposing, tension going up, force of gravity going down. So for our sum of the forces in the first one, we have the tension force to the right, positive, and friction holding it back equals m1a in the x. And then for the other one, negative force of tension plus the positive force of gravity equals m2a in the x. And so again, we still have two unknowns. We don't know what tension is, and we don't know acceleration, but we have two equations. And so in this case, we're going to do substitution again. We just have to be careful here with force of friction to designate what that is. We know the normal force is going up, force of gravity going down. If we look at the sum of the forces in the y equals ma in the y, right? We have the positive normal force plus negative force of gravity equals 0. So those are balanced, and that is mg, right? So what we're going to do is, for here, we're going to leave it like this. It's going to be the normal force, which is mg, so m1g times the coefficient of kinetic friction, which is 0.2. So that is where you don't want to put numbers in there yet. You're just going to leave that as, in variable form. Tension, we've got there, and then mass 1 times a. And so, okay, so the easiest way to do this is to go ahead and isolate for force of tension in variable form. We can bring the force of friction to the other side. And then when we substitute this, we have to be very careful. If you notice, as we place this in here for the negative force of tension, we're going to have to distribute that value. So this will become negative m1a minus the coefficient of kinetic friction times m1g plus m2g, which is for force of gravity, the other one, equals m2a. And so now our only unknown is the acceleration. So we can manipulate our equation here to do that. And we've got our values there. We can continue. So we have acceleration is negative coefficient of kinetic friction times m1g plus m2g over m2 plus m1 And for these values, we should get 1.96 meters per second squared. And if we solve for our tension, 39.2 newtons is the force of tension. Okay, so this is the same values as the last problem, and what we're going to do now is evaluate the static friction. And that last one we've seen that the object's moving. So let's see if that's even possible. If we, release this mass, will it actually accelerate? So remember, if the force of gravity is greater than the friction, it will start to move. So why don't you go ahead and pause the clip and see if it will be more, and if it is, then we'll know that if we released it, it will actually happen what happened in the last problem. Yeah, we can evaluate it from there. Okay, so in this case, the force of gravity would be 49 newtons of it going down here, as composed to the coefficient of static friction, which is only 29.4, so it will start to move if we release it, and it'll accelerate at the rate that we found earlier. Okay, so on this one, we have some different values of friction. So the first thing you want to do is figure out, will it move? And then if it will, then go ahead and figure out what the acceleration of the system is and what the force of tension is for the system. And so go ahead and try to work this completely from scratch. Don't look at the previous one if you can help it. Try to do it all from scratch, and then you can hit play when you're ready. Okay, so you should have gotten for the acceleration 5.684 meters per second squared is the acceleration, and the accidental tension force of 98.784 newtons. Okay, so this one is a modification of this one. Let's say that someone pulling up on mass 1 here with 20 newtons of force, and what would the acceleration of this system be? So someone's pulling up on this one, making the values change, right? So the normal force is not going to be equal to the force of gravity. And so why don't you go ahead and set up the sum of the forces, or the free body diagrams for both. Set up the sum of the forces, and then just set up that first, and then we'll make sure your progress is okay before you bring the equations together. Okay, so let's see how you did. We have a little bit of force supply coming up here, and so therefore, yeah, we know that the normal force here is going to be a little bit less, 97.6. The friction is only going to be 31.23 in this case, and so yeah, so it's going to move. If we substitute our values in here, everything's actually going to look the same, except normal force is going to be a little bit different here than it was before. In this case, we can just leave it in terms of normal force if we want to. And that'll be helpful for us. And so what we can do is we can just go ahead and plug in what the normal force value is here and determine the acceleration. So if we look at the normal force here, right, we have the positive normal force plus the negative force of gravity plus the positive force applied equals 0. So this is 20. This is mg. This is what we're looking for, and we can place our values in there, and we should get a acceleration of 5.83 meters per second squared and tension of 44.58. So the acceleration will change as well as the tension that's felt because there's a little bit less friction, less tension having to pull it down.